Raise your hand if you've ever owned a problem that 3 other teams thought was theirs to ignore. We had a test suite that was flaking 40% of the time. 40%. Nearly every other run red for 6 weeks. Nobody fixed it. Not because nobody cared, but because nobody owned it. The developer said that the tests were written wrong. That was a QE problem. The QE team said that the tests were fine, the environments were inconsistent. That was a platform problem. The platform team said that the environments were stable, that the test data was stale. That was a data team problem. The data team said that the seeding scripts were running fine. They were just running in the wrong order, which brought it back to QE. 6 weeks, 3 sprints, 0 progress. The failure mode didn't live inside any team's boundary, so it lived in a space between them all. What fixed it wasn't a better test, it wasn't more stable environment or clearer data. It was somebody deciding to own the whole shape of the problem, not the piece that belonged to their team, but the actual shape. And that's the story I want to tell today. I'm a QE by background, and when I walked into that situation, it felt familiar, not as a failure mode, but as a discipline. Quality engineering is the first engineering function that I know of that was architecturally required to work across the whole system to do its job. You cannot test software if you only reason about the code. You have to reason about the spec, and the infrastructure it runs on, and the data it depends on, and the user that's going to find that edge case that nobody thought to test for. Quality engineering developed peripheral vision by necessity. You don't get to stay in your lane because the bugs don't live where you find them. They live where you look. And if you only look at the code, you'll keep finding symptoms, while the cause may live somewhere entirely different. When I moved from quality engineering into platform engineering, I realized I was doing the same job at a different altitude, same instinct. Who else is touching the system? What breaks at the seams? And what work is falling between the chairs? Just operating at a much bigger surface area. Platform engineering isn't a new discipline that happened to recruit some quality engineers. For me, it's quality engineering's job, one level up. And I think that framing changes the kind of person that you should put in charge of your platform team and what you should charter them to do. The first problem I want to look at today is release confidence. And I want to be precise about what I mean by that, because it's not a deployment. Deployment is a technical event. Release confidence is an organizational belief, the belief that what you're about to ship is safe. And if it isn't, you'll know fast enough to do something about it. In most organizations, release confidence is assembled manually. Somebody checks the test report. Somebody else checks the environment status. Somebody approves the change request. Somebody monitors the rollout. These are 4 different people in 4 different teams with 4 different definitions of good enough. The release train leaves when everyone individually says, I think it's fine, not when the system collectively verifies that it is. What happens when a siloed team tries to own this? Whoever holds that final gate hoards the decision and becomes the bottleneck. The other teams optimize for getting past them, not for actual confidence. You end up with green dashboards, but amber reality. What changes when platform owns the whole shape? You build release confidence as a pipeline output, not as a pre-flight checklist. Quality gates, compliance checks, rollback capability, canary analysis. These aren't steps that different teams perform in sequence. They're a continuous signal that the pipeline produces. No team is the gatekeeper because the pipeline is the gatekeeper. The release decision becomes a read, not a meeting. The second problem to look at today is the developer feedback loop, which sounds like a DevX problem, and it is, but the failure mode is a platform failure, not a developer experience failure. Here's a specific version of that problem. A developer pushes a commit, runs the pipeline, and 45 minutes later, a test fails. The developer has context switched twice, started something else, and has to reload that mental model of what they were working on an hour ago. They fix the obvious thing, push again, and wait another 45 minutes. Whose problem is this? The developer says, make the tests faster. That's a QE problem. The QE team says the tests are as fast as they can be given the environments. That's a platform problem. The platform team says the environment provisioning is as optimized as it can be given the architecture. That's a dev problem. Nobody is wrong, but nobody's right. The developer is still waiting 45 minutes per feedback cycle. When you own the whole shape, the question changes. It's not who is responsible for test speed. It's what is the end-to-end time from code change to actionable signal? And where is that time going? That's a different question. It can only be asked by someone that can see across the pipeline, the test architecture, the environment configuration simultaneously. And when you answer that, you usually find that the 45 minutes is not a test speed problem or an environment problem. It's a sequencing problem. Tests running in the wrong order, blocking on resources that are already available, or retrying failures that a smarter orchestration layer could have caught earlier. The third problem is a newer one, and it's where I think platform engineering gets its most interesting mandate in 2026. AI eval pipelines. Every engineering team now using AI generated code, which by now is most of them, needs a way to evaluate the quality of the AI, of what the AI is producing. Does the code do what the prompt asked? Does it introduce security vulnerabilities? Does it behave correctly at the boundary cases? And is it consistent with the architecture decisions that we made 6 months ago? These questions sit across data science, development, security, QA, and infrastructure simultaneously. An eval pipeline needs ground truth datasets, which is a data problem, test harnesses, which is a QE problem, runtime environments, which is a platform problem, security scanning, which is a security problem, and latency and cost measurement, which is an infrastructure problem. If you ask each of these teams to own their slice, you get 5 fragmented components that don't compose. Nobody knows if the end-to-end evaluation is producing a reliable signal. The AI keeps shipping, and nobody knows if the quality is actually going up. This is the purest expression of that whole problem mandate. An AI eval pipeline is not a test suite, it's not an environment, it's not a data asset. It's all of those things in a feedback loop. And somebody needs to own that loop. Platform teams, with their cross-functional instinct, their orchestration reflex, are the natural home for this. Not because they know the most about AI, because they're trained by necessity to own problems that don't fit inside one team's boundary. 3 different problems, 3 different technology surfaces, 3 different sets of stakeholders, but the same shape. In each case, the problem didn't live in one team's domain. In each case, siloed ownership produced ping pong, not progress. In each case, what changed the outcome wasn't better tools or more headcount. It was someone taking accountability for the whole shape. Release confidence, developer feedback loops, AI evaluation pipelines. These are orchestration problems. And I'd argue that orchestration, not infrastructure, not tooling, not golden paths, is the actual product of a platform team. When you think of it that way, the job description changes. You're not building a Kubernetes cluster for developers to use. You're building a system that turns code into confidence at scale across every team that ships in your organization. The system has 1,000 moving parts. Most of them belong to other people, and your job is to see how they fit together and own the gaps where they don't. So here's the practical implication I want to leave you with, and it's not a checklist. If you're building or scaling a platform team, stop hiring for Kubernetes depth or Terraform fluency or whatever the fashionable infrastructure credential is this year. Those skills matter, but they're learnable, and they're not what makes a platform engineer excellent. What makes a platform engineer excellent is what I'd call the orchestration reflex. The instinct to ask, who else is touching this? What breaks at the seams? Where is that work falling between the chairs? And who is chartered to pick it up? The best platform engineer might be a QE who got curious about why the environments were always wrong, or an SRE that got tired of being that last line of defense of problems that could have got solved 3 stages back, or a developer who kept asking why the feedback loop was so slow and never having a satisfying answer. The through line is temperament, not CV. And if you're a platform engineer watching online, you probably already have this instinct. What you might not have is the explicit permission to use it, the mandate to cross boundaries, the authority to say, this problem lives at the seam and I'm going to own the whole shape, not just the part that fits my job description. That's the mandate I'd like to give you today. Not the tools, not the tech stack, the permission to be the person that sees the whole system and the relentlessness to care about every part of it that's broken. A platform team's best feature isn't its API, is its peripheral vision.